A couple quick things before we start. I want to do a mea culpa, which is to say I messed up, on the repeat rule. So I was telling you something that is not strictly speaking correct about the repeat rule. What I was telling you is you got to use repeat anytime you want to use a line in a subderivation. And a student helpfully came up to me after class last time, and the justification I gave you was Logic 2010 makes you do this. And a student came up to me and said, actually, it doesn't. Logic 2010 doesn't require the repeat rule anytime you bring something into a subderivation. So it only requires you to do this when you're bringing something into, using something in a direct derivation or an indirect derivation line. Okay, let me show you what I mean to make this clearer. So here. Okay, so here's a derivation we might want to do, show conclusion. It's a conditional, so of course we assume for conditional derivation and try to show the consequent. The consequent is itself a conditional, so we assume for conditional derivation to show the consequent. Now this thing is not a conditional, so we're going to assume for indirect derivation. Why? Okay. Now, what I was telling you was, so for example, I want to be able to use, so one obvious thing to do here is to use x and premise 1 and premise 2. And what I was telling you was that you had to do 2 repeat premise 1 modus ponens. And that does work. You won't get the wrong answer by doing what I said. But what I said was that you have to do this, and that's not strictly speaking true. So you can do this. You can just say line 2 premise 1 modus ponens, and that works too. So what I'm going to say is if you do it this way, it's fine. If you do it this way on the test or the exam, you don't use repeat, that's fine, except in the following circumstances. So 2 premise 2 modus ponens, and then we do line 6, 7 modus ponens, 8, 9 modus ponens. Okay, now here's where you actually need the repeat rule. So what I've got, I'm doing an indirect derivation here, and I've got my contradiction. I've got not P and P. But if I try to do the following, it won't let me. So it won't let me just go line 4, line 10 indirect derivation, because line 4 isn't inside the current derivation. So I'm trying to write my ID line, and I'm trying to use a line from outside my subderivation. Logic 2010 won't let me. So what now is when you need the repeat rule. Now you have to say line 4, line 10 indirect derivation, and now that's okay. Okay? So it's when you're writing these lines to close off a subderivation that you need to repeat anything that's not in the subderivation. So I propose to follow that rule for our tests and exams. That is, we're only going to require the repeat rule to write these ID lines. It also is required for a DD line for a direct derivation. If you want to close off a direct derivation with something outside of the subderivation, you have to use repeat. So basically what I'm saying is we're going to follow the Logic 2010 rules. You won't get in trouble if you use the repeat line when you don't need it. It's just extra. It's unnecessary, but it's not wrong. So if you do what I said before, you won't get it wrong. I'm just saying you don't have to do what I said before. Is that fair? Okay. In general, the rule is going to be if Logic 2010 lets you do it, then you're allowed to do it on the exam. That'll be our general rule. There's a few things like Logic 2010 has some rules that aren't part of what I'm going to present to you, and that's outside of our, you can't use rules that are in Logic 2010 but that I'm not allowing. But otherwise, anything that a legitimate defense for an answer on your test will be, well, I put it into Logic 2010 and it worked. That would be a very convincing argument to me that what you did was okay. Okay? Okay. I apologize for the confusion there. It was mine. Okay, so we're going to follow the Logic 2010 rules for consistency just between all of the elements of this course. Any questions about that? Okay. One other thing that I thought I'd mention, I put so far 2 quick short videos on supplements for the controls for Logic 2010. Those are posted in amongst the lecture recordings. Just the real basics of how to do derivations are what I've been doing. So if you're still confused about how to use Logic 2010 to do derivations, check those out. and I do request. So if there's something else that you want to see explained carefully and slowly in a calming voice, just ask me, email me, ask me in person. If you want me to go through some extra derivations. So I'm going to fill up these classes with first presenting the material and then doing examples for as much time as we've got. But maybe you want to see a few more worked examples. I can do those and just post them to YouTube. But if there's something specific you'd like to see, let me know and I can do that. OK? OK. Any course questions before we get into the new material? Questions about the structure of the course, stuff like that? OK. So today we're introducing 3 new connectives: and, or, if, and only if. So those are in addition to the conditional and the negation. Okay? So our system is becoming more complicated, and will continue to become more complicated throughout the semester. Today we're just going to do what these connectives mean and how to use them in symbolization. And next week we'll start introducing the rules that you can use for these connectives in derivations. So we'll do that next week. This week we'll just do the basic idea of these and how to symbolize sentences that contain them. Okay? So, and I think these are they should be fairly intuitive, actually. These are, I think the reason why the conditional was presented first is because it's the hardest one. These two, the conjunction and the disjunction, are fairly intuitive. So conjunction P and Q is true just in case P is true and Q is true. You can tell it's intuitive because I don't have another word in my language to explain it other than the one that's in the logical system. In any other case, it's false. If I say it's raining and I'm happy, and it's either not raining or I'm not happy, then that whole sentence was false. Yeah? This should be straightforward. OK. Disjunction is true just in case. So P or Q is true just in case P is true or Q is true or P and Q are both true. And false only in case both are false. Okay? And the biconditional is like if P then Q and if Q then P. The biconditional is true only in case the P and Q have the same truth value. So if P is true and Q is true, it's true. If P is false and Q is false, it's false. Or sorry, it's true. And in any other case, it's false. OK, this is just by way of showing you the very basic, these are the truth tables for these conditionals. OK. So how do we write these things down? We once again have parsing problems related to these. So there's parsing problems in this week's exercises. The official notation for these things is just the same as the official notation for the conditional. That is, anytime you put 2 sentences together with a conjunction, a disjunction, or a biconditional, the official notation is to put brackets around it. Yeah? Easy? Informal notation here is a little bit trickier. So for the informal notation, if you have a mixture of a conditional and either a conjunction or a disjunction, then we're going to assume that the major connective is the conditional. Assume, so if you see the thing on the top, we're going to assume that it says the thing on the bottom. So we didn't put it brackets in, we didn't clear it up with brackets, but if you don't see the brackets, then the conditional is the major connective of that sentence. This is blatant favoritism towards the conditional. Hey, why is the conditional the special one that always gets to be the major connective? No particular reason, but that's what we're doing. So, okay? And it doesn't matter what order it's in. So if you see P or Q then R, we're once again going to assume the conditional is the major connective. Yeah? So we just default to that. Now you can make it not the major connective. So if you use your brackets, sorry, and the same thing for the conjunction. Sorry, this is just exact same thing. If you see a mixture of and if then the if then is the major connective, assumed to be the major connective. And the same thing for the biconditional. biconditional is also assumed to be the major connective. Top thing is in informal notation. The bottom thing is also technically an informal notation because if it was official, it would have brackets around the whole thing. But it's more official. OK. So in general, the conditional or biconditional is the major connective unless the brackets tell you otherwise. So here, I've made the or the major connective by using brackets, right? If you put brackets around the biconditional, then now the major connective is the or statement. Yeah? Yeah?
If you have conditional and biconditional, does the conditional take precedence over the biconditional?
No. So good question. So if you with no brackets, if you have a conditional and a biconditional, that's just not well formed. In the exact same way that if you have if P, then Q, then R, and there's no brackets, that's not well formed. Yeah? So here, let me just. So if you saw this, that's not a well-formed sentence. And if you saw that is also not a well-formed sentence. With conditionals, you always have to add the brackets because there's no way to, I guess it's blatant favoritism towards conditionals and biconditionals. But since we've got a conditional and a biconditional here, we have no way of applying our blatant favoritism, so this is just not well-formed. Yeah? Okay, good. Okay. If you've got a string of disjunctions, then we're going to assume that the first disjunction gets the brackets, just whichever one's first. Similarly, with the conjunction, we'll assume that the first one gets the brackets. But notice that it doesn't actually matter. Notice that the truth values are going to be the same wherever we put these brackets. If you've got just all ands, then this sentence is true if P is Q and Q is true and R is true, and false no matter in any other circumstance, right? Because we need them for a conditional, or sorry, a conjunction. They both got to be true for the whole thing to be true. And this is just a conjunction and another conjunction. So they all three have got to be true for this thing to be true and false under all other truth values. And the same thing for this. It's just the same, right? They all got to be true or the whole thing's false. So actually, in this case, it kind of doesn't matter where you put the brackets. Nonetheless, we have a convention if you like knowing what the major connective is. We have a convention. Similarly, and similarly for disjunctions, for OR. So if you have P or Q or R, again, we're going to assume that the first thing gets the brackets, but it doesn't really matter because P or Q or R is true. If P is true or Q is true or R is true, they all have, so in that case, the whole thing is true unless they're all three of them false. In this case, it's true in case they're all true and false otherwise. If these were all or statements, then it would be true. It would be false unless, and it's false if all three of them are false, but true otherwise. Okay. Okay. Okay, so that was just by way of showing you. So we have a convention, but the convention doesn't matter so much in this case. Yeah? Okay. Now, if you're mixing conjunctions and disjunctions, then it does matter. By the way, just a quick memory device for remembering which one is and which one is or. Or is like a person sticking up their hands and being like, this one or that one, it doesn't really matter. And then and is like somebody putting their hands down on the table. It's like, no, it's this and that. Right? It's a very determined gesture. It's like, no. And then or is like, no, whatever. Okay, so or is the permissive one and is the demanding one. So you can remember it imagining a little stick person.
Or you doing this.
Yeah.
That's gonna help with the test.
Yeah, so if I see you on the test going like this, I'll know you're trying to remember that which one is which. Okay. Okay, so but if we said, I was just telling you that if you have a string of ands, and, it doesn't really matter where the brackets go. But notice that if you have an and an or, now it matters. Now we get different, so if you assign different truth values to these, you can get different truth values out. So suppose we parsed the sentence this way or that way, where either the first thing is the and here, on the left the and is the major connective, and on the right the or is the major connective. Yeah? And then suppose we assign the following truth values. We say P is false and Q is false and R is true. Okay? So on the left here, this and statement, so supposing this is the major connective, this and statement is only true if both halves are true. And here P is false, so the whole thing comes out as false. This or is true if either P or Q is true. So this one comes out as true. So you got one truth and one false feeding into this and statement, but the and is demanding and wants them both to be true. So it comes out as false. Whereas if the or is the major connective, it doesn't matter that P and Q are both false, so this and comes out as false, but R is true, and that's good enough for or, so the whole thing comes out as true. So given the same assignments of truth values to the atomics, you can get two different answers out if you don't put in the brackets. So that's why we need the brackets here. We need to distinguish between these two things, right? They're not the same thing. So I believe if you don't include any of the brackets, it's just not well formed, right? So you can't just sort of assume that it's the leftmost thing. If it's a mix of ands and ors, don't assume it's the leftmost thing. You have to have the brackets. Okay? So far, so good. Okay. So that was so far I've just introduced you to the connectives. I've shown you the truth tables, and we've talked a little bit about parsing. Now let's move on to symbolizing these things. So this will complicate our symbolization considerably. We'll start with and. And just to flag this is another place where all of your subtle, complex, rich human understanding of language is going to get in your way here. It's holding you back. Your humanity is holding you back here. So try to abandon it as much as possible. So you might think, for example, that there's a difference between saying X and Y and X but Y. I'm happy and I'm going to the party. I'm happy, but I'm going to the party. Right? You're saying in the realm of humans who know what implications are, those are very different sentences. I'm seeing Angela tonight, but I'm happy. Versus I'm seeing Angela tonight and I'm happy. Okay. So you can feel that there's a big difference in terms of the human level meaning of those sentences, but in our system, all that gets chopped out. And but for our purposes mean the same thing. They just mean conjunction, X conjunction Y. Okay, so if I say I'm seeing Angela, but I'm happy, you're saying it's true. That statement is true if you are seeing Angela and you're happy, right? So the truth value of that is just determined by the truth value of its parts, right? And the but just says this thing and that thing are true. It's counterintuitive. Similarly, X although Y. I'm seeing Angela, although I'm happy. What you're saying is X is true and Y is true, right? So the truth value of that whole sentence is just determined by whether X is true and whether Y is true. the implications of that go well beyond just the truth value. So this is a lesson on, that language is not reducible to just whether your sentence is true or false. In general, it's not reducible to whether your sentence is just true or false. But our system is just about whether the sentence is true or false. So that's why this all gets chopped off. We just care about the truth values. So x and y, x but y, x although y, x even though y, even though x, y, despite x, y. Those all end up being symbolized with just the conjunction. They all end up symbolized exactly the same. Yeah? Okay, so there's a bunch of variants on and. You can just say x semicolon y. I'm going to the party. I'm happy. That's equivalent to x and y. Okay. Is that reasonably clear? Have we successfully abandoned our human understanding of the subtleties of interpersonal relationships and just boiled it all down to the truth values of sentences? Yes, good. Yeah, we're doing it. Okay. Not both is symbolized as the following way. It's symbolized as the negation of a conjunction. So notice the negation applies to the whole conjunction here. We're saying not P and Q. So not both Peter and Quincy came to work today. Not both Peter and Quincy came to work today is true if Peter came but Quincy didn't, or Quincy came and Peter didn't, or Peter didn't and Quincy didn't. Right? So it's not the case that both of them came. It has the implication that one of them came. So it has this sort of implication is the wrong word. It has the implicature. You wouldn't say this sentence unless one of them came, right? But what you would or wouldn't say is, again, one of those human things. It's one of those things about the subtle, the subtleties of language rather than the truth values of language. This sentence is true in case Peter didn't come, or Quincy didn't come, or Peter and Quincy didn't come. Yeah? Not both is the negation of a conjunction. Okay? Okay. So that was and. Let's do or. X or y. Either x or y. X unless y. That's the one I found hardest to wrap my head around. X unless y. It sounds like there's an implication here, right? X unless y. So I'll be hungry unless I eat lunch. Well, that's true if you're hungry or if you eat lunch. The counterintuitive bit here is that it's also true if you ate lunch and you're hungry. That's how our or works. It's an inclusive or, which we'll talk about in a second. So unless works exactly like the or. You're all quiet today. It's okay. Do you want to just accept this and move on? In some sense, I recommend just accepting this and moving on, just memorizing that unless means disjunction. If what you're wrestling with is the subtleties of human language and how this doesn't quite fit it, then that's good. You're a sensitive and intelligent person, but you're going to be disappointed by how we deal with things in this course. So if that's the problem here, then just sort of accept this and we'll move on. Okay? Okay. This does get us to this question of inclusive and exclusive disjunctions. We very briefly talked about this before, but let's do it again. So, or in English can mean two quite different things. If I say, I'm going to the party or I'll be happy, the implication there is it's going to be one or the other, right? So the exclusive disjunction, right? That's what that sounds like, right? That's the ring of it. But for our purposes, or is always going to be the inclusive one. So in our logical system, that V shape is always going to be the inclusive disjunction. So it's true if one of the things is true, or the other thing is true, or both of them is true. It's the most permissive version of or. Yeah?
There's a mistake in the truth table.
Oh, yeah? Wait, where?
Should, for the inclusive or should in all cases except for the last be true?
Yeah, that's absolutely right. Yeah. Thank you. Bam. Bam. Thank you. Yes. Sorry. So this is the one, this is the truth. Hopefully this is the truth table I showed you earlier. That it's true no matter, it's true in any case except where they're both false. Thank you. Yeah.
For the exclusive one, wouldn't false be, oh wait, never mind.
Yeah.
I'm good.
I hope I got this one right. Right. Okay. So in English, once again, in English, or could mean either of these things. Right? You're not wrong to think that sometimes or has this exclusive quality. You're saying, well, it's not both of these things. But in our system, or is always going to mean inclusive or. Okay? Okay. Here's another one. Neither nor. Neither this nor that. That's the negation of a conjunction. You say, I want neither fries nor salad. You're ordering a meal, so I get the burger. Do you want fries or salad? No, I would like neither fries nor salad. So when have they got your order right? If they bring you fries, did they get your order? If you say, I want neither fries nor salad, and they bring you fries, did they get your order right? No. No. So if X is fries and Y is salad, we need both X and Y to be false in order for this whole thing to be true, right? Which is logically equivalent to not X and not Y, right? So not X or Y comes out exactly the same as not X and not Y, neither nor. So if on a test you symbolize it one way or the other, they are exactly as good as each other. Yeah? So far, so good? Okay. Now, just working up, so that was the disjunction. We've done conjunction. We've done disjunction. Now we're going to do the biconditional. So just recall, because the biconditional is just putting together conditionals that go both ways. So recall these equivalents to if and only if. X, if and only. Sorry, yeah, these are equivalents to if and only if. Sorry, these are equivalents to the biconditional. X, if and only if Y. So I think I've only ever heard philosophers use that style of phrase, but nonetheless. X exactly on the condition that Y. X just in case Y. Yeah, like philosophers, mathematicians, computer scientists, the only people in the universe who speak this way as far as I can tell. However, the last one, scientists sometimes use. X is necessary and sufficient for Y. And they use it wrong a lot of the time. It's disturbing. So they say a gene is necessary and sufficient for this effect. They say this regularly, and they use it completely wrong. Okay. So let's do necessary and sufficient. Okay, so now we're taking a step back. We're talking about how to symbolize conditionals. We're going to do how to talk about necessary and how to talk about sufficient. So here are a bunch of things that are equivalent. So these should all be symbolized in the same way, right? How should these all be symbolized? Conditional, which is the antecedent? P, and then Q. So if P, then Q. So these all get symbolized as if P, then Q. So if P, then Q. Q only if P. No, that's wrong. That's wrong. Because the consequent comes after only if. Right. Q if P. And then, did I get this wrong before, or did I get it wrong now? Which is it? Remind me.
You had it
I had it right?
last one.
Oh, hilarious.
So you just have to say the little what.
Whoop. So, these should all be the same. It was the goal. If P, then Q.
Because you have only F twice, and then you have them flipped.
So one of them has to be wrong.
Yeah.
So, but this one was wrong too. So I think that last one was right and this one was wrong. Okay, so after only if comes the consequent. So this one is wrong. This is all a test to see if you're paying attention. It's a test to see if I'm paying attention. Okay. But this next part I'm confident is right. I do apologize. Okay. So, if P then Q should be, let's just get onto this. So, necessary and sufficient. If you're a dog, then you're an animal. Sounds right, right? All dogs are animals. If you're a dog, then you're an animal. Right? So what I'm saying there is the set of dogs are strictly contained within the set of animals. That's okay, right? I got that one right. Okay. Being an animal, so with necessary and sufficient, we should say being an animal is necessary for being a dog. There's no non-animal dogs. Being an animal is necessary for being a dog. And being a dog is sufficient for being an animal. If you're a dog, then you're an animal. Yeah? Okay, so back to this embarrassment. Yes, this should have said, only if Q then P, right? Is that right? I think that's right now. Okay, so P is sufficient for Q is if P then Q, which is exactly the same as saying if Q is necessary for P. Do you see how they are flip sides of the same basic claim? So if you're a dog, then you're an animal. If D, then A. Those aren't proper sentence letters, but and being an animal is necessary for being a dog. Being a dog is sufficient for being an animal. And what we're saying is just about set containedness. Okay. Now, if I said something is both necessary and sufficient, what am I saying about those two circles? Yeah.
You're literally saying if and only if.
Yeah. You're saying if P then Q and if Q then P, which means that the set of P is strictly contained within the set of things that are Q, and the set of things that are Q are strictly contained within the set of things that are P. So what I'm saying is these circles overlap exactly. So anything that's P is Q, or anytime P is Q, Q is true, and anytime Q is true, P is true. So necessary and sufficient, which is our if and only if. Yeah? This is biconditional. The biconditional is equivalent to if P then Q and if Q then P. It's just two conditionals going in opposite directions. Yeah? Okay. Just to briefly highlight what we're going to do next time, you can think about what rules are going to apply here, right? So the rules that we're going to use in derivations are mostly fairly intuitive for these. So if you've got P and Q, what can you get from that? You can get P and you can get Q. Yeah? And if you've got P and if you've got Q, you can get P and Q. Similarly, if you've got P, you can get P or Q. You can add anything onto in a conjunction, any random thing. And if you've got if P then Q, and you got if Q then P, then you can get P biconditional Q. Yeah? Okay, we'll do that in great detail next time. For now, let's do some examples of these symbolizations. Yeah? So a few straight from the textbook. Okay. So when you're doing symbolizations, the strategy is always to try to figure out what the major connective is, right? First, we're trying to break this sentence down into its biggest parts, and then we look at the smaller parts within that and try to break those down into parts, and so on and so on. So this one should be fairly straightforward. Veronica won't leave if and only if William won't leave. Yeah.
Not V if, not W.
Yeah. So not V if and only if, not W. So Veronica won't leave if and only if William won't leave. Is that obvious how we got there? So this is a complex chunk. It's still a complex chunk. Veronica won't leave because it's a molecular sentence. Veronica will leave. Veronica won't leave. William won't leave. William will leave. William won't leave. Yeah? Okay. That one should have been easy. Do a slightly more complex one. Okay. William and Veronica will both leave if Yolanda does, provided that Veronica doesn't. Please don't ever talk this way, or people will know what you're saying, but okay. So again, we start from trying to figure out what the major connective is. What's the major connective? And there's a hint here. The hint is the comma. The comma should be used in a sentence, in a well-written sentence. The comma tells you where the main break in the sentence is, how to break the sentence up into its relevant parts. So we've got two main parts before and after the comma. William and Veronica will both leave if Yolanda does, provided that Veronica doesn't. Okay. So these are our two main chunks. Now so provided that is our main connective, right? So provided that is what? It's a conditional. It's provided that is the same as saying if, right? If Veronica doesn't. Which means that we've got if not V. Okay, but anything that comes right after the if is the antecedent. So we don't do this second, we do not V, then this whole thing, whatever this thing is. Yeah? Okay, so now, yeah?
So would it be bracket y conditional
Okay, let's not jump to the end. Let's get to how you got, unless you want to explain how you got to the answer. So how did you break this up?
Okay, so you can see that it has if Yolanda, which makes Yolanda the antecedent.
Right. So okay. So let's do this a bit at a time. So we've got if. So this chunk is a conditional with two parts. Right? Okay. I'll do it. Mostly so that we get it on the recording. Okay, so this whole thing, whatever's in this bracket is itself a conditional, and you can tell that this part is the antecedent because it comes right after if. So Yolanda leaves is the antecedent, and then something. And the something is just whatever's left over, so William and Veronica both leave. William and Veronica both leave should be W and V. Yeah.
Do you need the brackets around the connectives?
Strictly speaking, no. So if I just done W and Y, that would be a well-formed sentence in informal notation. Because in here, we assume, according to our rule of blatant conditional favoritism, that the conditional is the major connective. And all I did by putting these extra brackets around here was just reinforce. I just said again that this is the major connective in this sub-sentence. Yeah? Questions, concerns? Oh, yeah. Thank you. V. Yeah. Okay? I'm going to do another. Okay. These are all from the textbook. Sorry, question? Yeah.
If you feed the truth values into that sentence, the not B is true, Y is true, and W is true, then how can you have the result that B would also be true? Like, wouldn't that be contradictory? B is both true and not true?
How did you get truth values for these?
Like if I'm just feeding those into that.
Okay, so tell me again what the truth values you wanted were.
So not B,
Not V is true,
yeah.
okay, which means V is false. Yeah?
And then
Y
Y is true,
is true,
W is true.
and W is true. Okay, so now we can evaluate the truth. Given these truth values, we can evaluate the truth of the whole thing. So W and V, that comes out as false, right? Because we don't have two true things. You need both of these to be true for this to be true, so this is false. And if the antecedent is true and the consequent is false, this comes out as false. And now we've got a conditional where the antecedent is true and the consequent is false, so this comes out as false.
Okay. So it's okay to have a false sentence. It's just that's what we practice.
Yeah, I mean, these sentences are by no means guaranteed to be true. Yeah, yeah. Okay. So that was, by the way, how you do, roughly how you do a shortened truth table. We'll do truth tables in not too long. Okay, another one. Either Yolanda leaves and Veronica doesn't, or Veronica leaves and William doesn't. Once again, the clue on, so starting off, we're going to try to break this thing down into its biggest pieces and then smaller pieces, smaller pieces. Do it one at a time and don't worry about the smaller pieces until you figured out what the major structure is. This is how you, I mean, now it's not that hectic, but it'll be testing your working memory. By the time we get deep into this, we'll be testing your working memory if you try to deal with every single part of it all at once. So it's a matter of like asking yourself one question at a time. The question you ask first is, what's the major connective? And if you've got a comma, that's your clue. So, comma, or Veronica leaves and William doesn't. So there's a chunk, and there's a chunk. So something or something else, right? Or. And now it's just a matter of filling in the smaller pieces. And either or is equivalent to or, right? So this either, sorry, we should maybe when you're drawing this out sort of exclude the connectives. So either blank or blank gives us this thing or this thing. So Yolanda leaves and Veronica doesn't. Either Y and not V, or Veronica leaves and William doesn't. Veronica leaves and not W. Yeah?
For official notation, would you have to put brackets on the side of the disjunction?
So yeah, official notation looks like that. Yeah. Yeah. Was that the sorry, was that the question? Yeah. Okay, good. Yeah. We won't require official notation on tests just because it's fairly, given this, it's fairly obvious what you mean. Yeah. Okay, let's try one more and then we'll be out of time. Only if Todd gets enough sleep will he be not both cranky and sad. Only if Todd gets enough sleep will he be not both cranky and sad. So, only if this thing will he be not both cranky and sad. Only if tells us what? What comes right after an only if? The consequent. So this thing is our consequent. And this thing is our antecedent. So Todd gets enough sleep is our consequent. Not both cranky and sad. So is our antecedent. Not both. We did this just today. Yeah? Good. So it's not the case that he's both cranky and sad. Yeah? Okay. So the question is this the same, not Q? And that actually has a different truth value. Because this whole sentence is true just in case P is false and Q is false. So you need both P to be false and Q to be false. So if you say P is false, then this thing is true. Q is false, this thing is true. Then this thing comes out as true. But in this case, it's not the case that both P and Q are true. It's true just in case P is false or Q is false. So this sentence, so this is not the same. This sentence would, however, be equivalent to not P or not Q. So this thing is true. If P is true, then this comes out as false. Well, that doesn't help us get this to be true. But if this is false, then this is true, and this comes out as true. So this sentence is equivalent. So if you'd said this sentence, then R, then that would have been good too. Okay, we're out of time. Thanks, everyone.